Hello, welcome. This is now Edexcel's June 2009 C4 paper. I forgot what exam it was here. Anyway, so this is question 2. And we're given this curve, which is got the equation 3 cos x on 3. And we're given this table which we're asked to fill out, okay? Most of it has already been done for us. We've only got to fill in the value where x is 9 pi on 8. So really it's just sub in 9 pi on 8 into 3 cos x by 3. Okay, so it wants it to 5 decimal places. And to 5 decimal places it's 1.14805. So that's, as I said, it's just simple putting 9 pi on 8 into the equation over here. As I said, you're given this in the exam, obviously. I'm just coming up with it now, that'd be a bit stupid. Alright, so essentially that's part 8 over and done with. It's only worth 1 mark, so you can see it's quite simple. Now, using the trapezium rule, with all the values of y from the completed table, find an approximation to the value of r. Now it says approximation because really we're going to have something where, something like that. Okay, but we've got trapeziums and obviously it's not going to follow the curve perfectly. You obviously know that. Now the trapezium rule is given in the back of your exam booklets or whatever you're given in the exam. Stupid formula books that are 20 pages long and the formulas look nothing like what you are used to. Okay, so I always recommend remembering the formula. Obviously, if you can. And it's h over 2, brackets y0 plus yn. Okay, so the first and last y value plus 2 times the remaining y values, so leave y1 plus y2 all the way up to the second to last one, yn take 1. Okay, so that's the area of, that's the trapezium rule. Now this h always gets people. H is equal to b take a over n. So b take a being the limits and n being the number of strips. But in C4 it's not going to be as nice as to tell you the number of strips. Okay, you've got to work that out for yourself. Now you could do that a number of ways, obviously by drawing it and counting up the number of strips. And if you were to do that, well, if you drew a line at each value of x up to the curve, it would look something like this. Okay, so obviously when x is 0 you want to draw one up. You draw one up 3 pi by 8, 3 pi by 4, 9 pi by 8 and 3 pi by 2. And if you counted the sections in between them, so 1, 2, 3, 4, 5. Maybe I've not drawn that right. No, sorry. There's not a 3 pi by 2 because that's the intercept, I do apologise. So there's 4 strips there. And essentially the case for any so the case for any question like this where if you're not sure of the number of strips, you always take 1 away from the amount of x values that they've given. Okay, because you could draw on each line if you wanted to and look at the amount of areas or trapeziums. There's probably a bit more mathematical way of saying it. There are in that sketch, but that wastes time. And it's always nice to just remember that. But if you're not sure, you can always pretend to sketch on these lines. Okay, drawing the trapeziums and obviously count the number of ones. But as I said, it's just nice to remember it. In working out h, well, obviously our top is limit is 3 pi by 2. Our lowest limit is 0. Okay, so it's obviously just 3 pi by 2. Over, we said, well, there's 5 values of x are given in, so it's 3 pi over 2 over 4, which obviously gives us, therefore, 3 pi on 8 as the value for the height of each trapezium. Okay, now we've got all the values, we just obviously pick out the individual values, sub it into this formula. Okay, so h over 2 is obviously 3 pi by 8 over 2, which obviously gives us 3 pi over 16. And then you simply sub in the first y value, so 3, the last y value 0, plus 2 times the remaining y values of 2.7. You need to specifically put them all into a calculator because, well, it's easy, and hopefully you want to pass. Okay, so it's 2.1232 plus 1.14805. Okay, now if you'd have put a different value for x being 9 pi and 8, but you'd have subbed that value into this equation, okay, for part B, you will obviously get a different answer for the area, but you wouldn't lose a mark apart from the answer. You wouldn't lose a mark in part B if you'd have done it according to your answer for part A. Okay, so that's why we have this carry on mark stuff, but really you should have got that. So what I was saying, you know, you would get a slightly different answer if you didn't get 1.14805. If you did just guess that, then you know, I think you deserve to leave the marks, but obviously they don't want you to. Okay, so if you were to work this out, it comes to 3 pi on 16 times 15.05 whatever. Okay, so if you simplify that down, obviously that comes to 42 pi-ish on 16, which is your answer, okay, for the area according to, oh sorry, it's not 42, 45, I do apologise, 45.25 over pi over 16. As I said, you could work that out, and I think it comes to about 8.08 or something like that. But as I said, it's nice to always leave it in exact form. But oh wait, sorry, no, it has to give you an answer to 3 decimal places. What the hell am I talking about? Okay, so to 3 decimal places. So obviously I did this. Obviously. It's 8.884, which is your answer to part B. Okay, so that's obviously you would put square units there because we're looking at area, and area obviously, you know, it's measured in square units, so it's always nice to put that if you want to pass. Now part C says use integration to find the exact value, the exact area of R. So this is why it is now obviously a C4 question. Okay, so basically what we're doing is integrating this equation y, but we're doing it between the limits of 3 pi and 2 and 0. Okay, so you just sub in y to 3 cos x on 3. Alright? And that's with respect to x. So obviously the first thing you would do is integrate that and sub in the limits. Right. So what we do here is when we integrate cos, obviously when we normally if we were to differentiate it, the sign would change. But because we're integrating it, the opposite happens. Okay, the sign doesn't change. But when we differentiate it, we times the equation by whatever in the little box, okay? The differential of what's being caused, essentially. Alright, but when we're integrating it, we divide it. So basically, the differential of this little cos, what's being caused, is a third. But we're going to be dividing by a third, so obviously that's the same as timesing by a third. Now you might want to do 3 sine x on 3 divided by a third, or you just might want to go straight to 9 sine x on 3. Which I would double check I've not gone completely insane. Yep, I'm completely insane. So then you just put your limits in of 3 pi on 2 and 0. Okay, so it's just a case now of subbing 3 pi and 2 and 0 into this. So the first one is obviously 9 sine x being 3 pi and 2 over 3, so that's obviously 3 pi on 6. Or you can just write 3 pi and 2 divided by 3, but obviously that comes to 3 pi and 6. Take 9 sine, see 0 and 3 is weirdly enough 0 in maths. Okay, so if you work that out, you would get a value of, obviously this becomes just 9, okay? So obviously we're just left with a value of 9. And don't forget to put that as 9 square units, okay? Because as I said, we're looking at area again, so don't be put off. Now you can see, obviously this trapezium rule is underestimating it, okay? As I kind of tried to demonstrate here, because we've got a little gap here, we've got a little gap here, and as you can see, that's why we've got this change. But if it asked you for the area, which has been underestimated, you'd obviously look at the difference between these two, and as I said, that would be the only other question it might ask. It might go on to say, well, very good, now we've worked it out, and this is what question I was expecting to see, excuse me, next. estimate the percent, or not estimate, state the percentage error. I was trying to think of the right word. State the percentage error used in the trapezium rule. Okay, and what you would do for that is work out obviously the difference between these two values, which would be, I don't know, 0.126 or whatever it might, 0.116 or whatever it might be. Okay, and then you would divide that by the original value and times it by 100 to get your percentage error. Okay, so that's the the correct. So it's the percentage error of the trapezium rule estimate. Okay, so hopefully that's cleared that up. That was just another question that you might ask, really, because I think this question was quite nice and easy, really. The only possibly tricky bit was dividing by a third, which obviously some people just took as the 3 cancel, it became sine x on 3. Remember, we're dividing by a third, so same as obviously times in by it. But that's simple maths, really. Okay, that was the only main kind of tricky bit of this question. And reading from the examiner's report, some people didn't put it to 5 significant figures. So it always helps to read the question, as you probably guessed from your time at college or whatever you do. Okay, so thanks for watching. I'll try to speed up these videos. If you want me to go back to doing the old slow, boring, dull, long-winded, shut up, get out of my face, I wish you could just close the YouTube channel, or there's a magical button, skip. Okay, so as I said, that's up to you. So anyway, thanks for watching, and hopefully cleared that up. If you want me to redo that again, please do let me know. But as I mentioned in my previous videos, I feel like I'm saying it too many times. Well, that's because I am. Okay, so really it's just a case of using the trapezium rule in that question. The paper hasn't been too bad so far, but in the next question, question 3, we're going to go on to look at partial fractions, which is a little bit more challenging, and it's only purely because we have to use ln's, and it's just using log rules, applying that and simplifying it down. So anyway, thanks for watching, and we'll see you in the next video.